In the northwestern Atlantic, a fabled, wind-swept crescent of land emerges from the sea.
The island is entirely made of sand, hence its name Sable Island, which is French for sand.
We call it a shifting sandbar because it constantly changes shape or width or length.
Sable Island is a pretty special place. It's an unlikely place to exist and an unlikely place to be.
Sable Island National Park Reserve is part of the province of Nova Scotia in Canada, so that's on the east coast of Canada.
Situated on the edge of the continental shelf, the island is located roughly 186 miles southeast of Halifax, Nova Scotia.
Sable Island is one of the most remote offshore islands in Canada.
It's a very harsh environment.
The island is famous for its bands of wild horses that roam the dunes and beaches.
The horses definitely hold a special place to a lot of Canadians. They're kind of one of the iconic features of the island.
Seals haul out on Sable year-round and arrive in large numbers in the wintertime.
It's the largest gray seal breeding colony in the world. There's over 300,000 seals that come to breed here annually. I love being able to see the seals and the horses in the same environment. That is just really unique.
Sable Island is a particularly important place for research for gray seals because they are a difficult species to study. They like to breed in really remote places. And so this is a remote place, but we have daily access to the breeding colony because we have camps at both ends of the island, so we can do research on this breeding colony, which there really is no opportunity to do that anywhere else.
How has the population of gray seals changed over time? And what are scientists learning about the animal's physiology?
Major funding for this program was provided by the Batchelor Foundation, encouraging people to preserve and protect America's underwater resources. Additional funding was provided by the Perot Family Endowment for Environmental Education.
It's winter on Sable Island.
We'll get winds that are almost hurricane strength. They are very strong winds in the wintertime.
It's one of the most difficult places to get to in Atlantic Canada. It's foggy, it's windy.
Infamous for its treacherous, shallow shoals, mariners nicknamed Sable Island the graveyard of the Atlantic.
Because it's a very low-lying island, and because this area is also surrounded in fog for about 127 days of the year, it was quite a navigational hazard to the ships that were coming across to North America.
There's 350 shipwrecks recorded around the island. It was feared by mariners and sailors for very good reasons.
Since December, gray seals have been arriving on Sable in large numbers.
They come here to give birth to their pups and to breed. As the females will come to shore, they're in their best condition for the year. They're really fat. They will give birth to a single pup each year, and they'll nurse that pup for, on average, about 18 days, so 15 to 20 days.
And they don't go back to sea to forage. They stay with the pup during that time. And they'll be very protective around their pup. About halfway through that period, the males start showing up and they really want to access the females. So you'll often see a male with 1 or 2, maybe sometimes 5 females around that he's defending. And she's there defending her pup and he's there defending her. The males will access the females while they're still nursing, and these females will be bred a few times before they leave the island.
Once a pup is weaned, the mom will return to the sea.
They go back and forage. Meanwhile, the pups are left on shore while they're figuring out what to do and developing a little bit more.
During this time, the pups also shed or molt their white coat, known as lanugo.
So they're born with that fluffy white lanugo, and that's because they don't have a lot of blubber yet to keep warm, and that lanugo traps a lot of air, like a down coat.
And then you'll see the fully molted pups that are silver or black or speckled.
And they just are bouncing around the island, curious and a little bit angry and very confident in their abilities for only being a couple of weeks old. So they're really fun to watch, and they all have unique personalities.
And they explore the island very well.
After about 3 weeks on land, the pups make their way to the sea.
And then they go out and have to explore the ocean and figure out how to forage. Sable, because we have this daily access to the gray seal colony and we have so many gray seals, it's an incredible place for research to happen.
Fisheries and Oceans Canada, commonly known as DFO, has been studying the gray seals of Sable for more than 60 years.
I'm now lead of the Sable Island research program that's been running since 1960s. And we come every year to study the gray seal population. So we're out here for the breeding season every winter, and often we're out here in the summer to do additional work on the seals. When this research program started, the gray seal population was at a low level because we had been culling seals throughout the eastern seaboard. That ended in the 1980s. And at that point, there were gray seals breeding on Sable Island, a few remote places on the eastern shore of Nova Scotia, and on the ice in the Gulf of St. Lawrence. In the 90s, the gray seal population increased on Sable Island at a very high rate, and so Sable became the most important breeding colony.
As the population recovered, seals re-established breeding colonies along their historical range in coastal Nova Scotia and into New England.
And more recently, they've been changing their distribution of breeding in the Gulf of St. Lawrence because the ice is no longer available to them in a reliable way. So now they're breeding on new colonies in the Gulf of St. Lawrence.
On Sable Island, DFO researchers spend 5 to 6 weeks each winter observing marked seals that have returned for the season.
It's been 40 years of very structured resightings that we do of these individually marked seals so that we can estimate survival and reproductive rates. Gray seals have a really high site fidelity for their breeding sites, so we will see the same seals year after year.
Every 10 to 15 years, a couple of thousand seals will be selected at random to be marked.
In their first year of life, we put a permanent mark on them, and then we get to follow them every year. They all have a couple digits and a letter. We have 8,000 seals that are uniquely identified. So every 5 to 7 days, we try to get out there and look at the backside of every seal. And if we see one, we'll stop, we'll take a waypoint, we'll write down the mark, the sex, the quality of our reed.
The research team also records the stages of pups born to marked females, ranging from newborn to fully molted. And some of these mom and pup pairs become part of a special study group.
We dye the mom and the pup pink so that we can see them at a distance, and we will go daily just to make sure the mom and pup are close together. And then on the first day that the mom leaves, we'll then weigh the pup to get a measure of her investment in her offspring and then the pup's chance of survival.
This so-called mark resighting study has provided important long-term population data.
In the 1990s, the increase was most rapid. Gray seals on Sable were increasing at the rate that is the maximum rate of growth you can have for a seal population, because these seals only have one pup a year. But since then it has slowed. Juvenile survival has been the key driver on the slowed growth rate. In the 1990s, we were estimating juvenile survival to be about 70%, and in the early 2000s, we estimated it to be down to about 30%, and we now think it's below 15%.
Researchers think the gray seal population may have reached carrying capacity, which is the maximum amount of animals the environment can sustain.
We have seals on the island that are almost 40 years old, and they start giving birth at age 5 or 6. So for a seal to live that long and give a pup every year, you don't expect to see juvenile survival of 70%. It is now a more typical survival rate to think that the pups are surviving at 15%.
Every 5 years, DFO also conducts aerial surveys of the breeding colony to count how many pups are born on the island.
We can estimate, based on how many pups there are, the total population. So the last time we did this in 2021, we estimated just under 80,000 pups born on the island, and that accounts for now 80% of the pups born in the Northwest Atlantic, and a population associated with that of between 300 and 350,000 seals. Fisheries and Oceans, we're very much interested in how many gray seals there are and their role in the environment. But the research program that we have here provides opportunity to collaborate with others who have specific research questions.
These collaborators include a team of scientists from the US that is studying the seal's physiology.
I'm interested in animal health and conservation and how animals interact with their environments and how that environment impacts them.
Led by ecophysiologist Dr. Michelle Shiro from the Woods Hole Oceanographic Institution, the team conducts in-depth workups of select mom and pup pairs.
When we catch the animals, it's quite difficult because they are quite aggressive and trying to defend their pups. And so we catch them with a V-shaped net, and we get the female secure first, and we get her kind of swaddled in this net. You gotta stay here. You gotta stay here. We weigh her so that we have an exact dose that the veterinarian should be giving the animals to keep them nice and sedate. 190.2.
So we're going to inject these medications into her tibial muscle.
We give her about 10 to 15 minutes for those drugs to start to take effect. And then she hopefully goes into a nice plane of sedation where she's not fully anesthetized, but she's a little bit calmer, still breathing on her own, still somewhat responsive to sounds and things like that, but otherwise she doesn't really know what's happening.
We're here for a project looking at iron physiology. The females who come back to shore and give birth in better condition, they do tend to wean larger pups that are fatter. And then those pups have more energy stored that they can live off of during that period before they go to the ocean, and also once they get out to the ocean. And so part of our question here is, what role does the iron play in that? So is it that pups that are weaned and have more iron, do they also do better and have more buffer when they go out to sea?
Iron is important in the creation of hemoglobin and myoglobin proteins, which carry oxygen throughout the body.
They have a lot more of those proteins than terrestrial mammals, and that's what allows them to dive for so long and be really effective at foraging. So they basically have these really big internal scuba tanks by having so much iron proteins.
Michelle and her colleagues are interested in how much iron is transferred from moms to their pups during lactation.
So we'll handle a pair and the pup's about 3 days old. We want to make sure that the mom and pup are bonded well enough before we come in. And then we also will handle them again at the very end of lactation to look at how the female's mass and fat stores have changed, and same for the pup, and how much iron she's given him. We're gonna weigh the pup, yep. It's 1, 2, 3. What are we doing? Yeah, 48.4. 48.4. Got it. Still a boy. They're born at under 20 kilos, and by the time they're weaned, they can be anywhere from, some of the wimpy ones are under 40 kilos, sometimes they're over 60 kilos. So they basically triple in size in just that 15 to 20 days. It's really incredible. And the mom loses about 30% of her body mass during that time. So it's just this enormous energy transfer from mom to pup.
To better understand this process, the team collects a whole suite of samples.
We take a whole lot of measurements of their body length and how wide they are, their girth. We take blubber depth measurements with a portable ultrasound.
Your baby's right there. When partially conscious, she's a very good mom.
We collect a ton of blood samples like you would when you go to your doctor. So we're looking at basic hematology. If you go to the doctor, they want to see if you're anemic and what your blood cell volume is and things like that. And so that's what we do for the seals as well. We collect a lot of serum to look at their energy status and stress levels with hormones that we measure when we get back to the lab. We use a lot of metabolic tracers as well. So we use labeled water, and we will inject that into each of the animals. The water will then dilute within the total body water in each seal, and then we can look at how much that tracer has been diluted. And because water doesn't associate as much with fat, we can use that to calculate the seal's lipid mass and how much that female is transferring to her pup across lactation. We've also been using iron tracers to track how the female is partitioning her iron, how much she keeps for herself versus giving to the pup, and then how efficient the pup is in being able to use the iron that's provided by the females.
Half of the pups also receive an iron supplement,
which is equivalent to a few extra days of lactation. So our question is, are those pups able to dive longer and deeper when they hit the water and do a little bit better?
Next, the researchers collect a milk sample to measure its iron content.
I always think it looks like Elmer's glue. It's just really viscous. And that's because seal milk has like 50 to 60% fat. So like when you think about your milk being 1 or 2% fat, the seals are just incredible. We also see that they have really high iron concentrations, where some seal species can have more than 100 times more iron in their milk than terrestrial mammals.
Experts are also taking a small muscle biopsy to measure myoglobin concentrations.
Oh, that's muscle. No, that's muscle. Okay, I'll go one more. You look at iron receptors in the muscle. And so my postdoc has been measuring the iron receptors, and she's seen this pretty interesting story where it looks like that directional transfer from mom to pup is set up by the mom has a lot more exporters in her muscle tissues, and the pup has a lot more receptors to internalize iron by about 6-fold, so that we think that's how that directional transfer is mediated.
Throughout the workup, veterinarian Michelle Rivard closely monitors mom and her pup.
The biggest part of my job is to really keep animal welfare at the forefront. We sedate the pup about halfway through mom's procedure. So we try to line the mom and the pup up next to each other, and that way I can monitor the sedation on both of the animals and make sure their heart rate is normal, their respiratory rate is normal, their mucous membrane color is nice and pink, and just keep an eye on all of those parameters that we like to monitor while they're under sedation. It's a normal part of their physiology for them to undergo periods of apnea, which is holding their breath, And while that's fine to do when they're awake, we don't necessarily want them to do that when they're under sedation. And usually it just takes a little bit of gentle stimulation, either flicking their nose, lifting their head to get them to start breathing again. So that's one of the things we really keep a close eye on.
The researchers are also curious to find out how the mom's diet might impact her pup's future success.
Females with higher iron-rich diets, are they able to provide their pups more iron? And then do those pups then do better as they start to go throughout their first year of foraging? If you've ever heard that phrase, you are what you eat, that's true. And so we collected a whole bunch of different tissues and we measure the stable isotopes in those tissues to get at the animal's diet.
Each prey has a unique, traceable isotopic signature that's reflected in the seal's tissues.
Those will be incorporated faster into blood than into hair and whiskers. We're trying to construct a timeline from a bunch of different tissues. And then DFO is also providing us with different fish species so that we can develop a library with stable isotopes of those fish and also measure the iron content of those fish to see how much they differ in their iron content.
Michelle is also attaching external heart rate monitors on the pups to study their energy demands and activities that determine their metabolic rates before they head to sea for the first time.
So I'm really interested in how the pup is developing, so how they're able to maybe pivot how much energy they're using. It would benefit those pups to have a really high metabolic rate and use energy quickly when the mom's giving them a lot of energy, because then they can use it faster and put it into stores faster and bulk up faster. But then when mom leaves, it would benefit them a lot more to be able to lower their energy use so that they can prolong how long they can live off their fat stores. And so one of our questions is, can pups pivot this? Are some pups better at it than others?
As the workup nears completion, it's time to administer a reversal of the sedative.
What we don't want is for mom to be reversed and her to have a sleepy pup that isn't going to follow her around the colony. So we'll typically reverse the pup first. That's a fun part of the job because then you get to stimulate him to wake him up, which is, usually involves a lot of puppy snuggles and pets to wake them up.
Wake up there, friend. Wakey, wakey. Hello. Oh my gosh. Wake up, Peanut. Wake up, Peanut.
So after that pup is reversed and awake, we'll give mom her reversal. Usually it takes effect within 5 minutes or so. And then after we reverse mom and pup, we make sure that they're reunited, that they're both alert. We make sure all of our gear is away because that reunion process is really important. So we want to make sure that we're still monitoring them, but we do it quietly and from a distance so that we minimize any disturbance.
She's a good mom.
Once the study pups have weaned and have shed their lanugo, they are outfitted with a satellite tag.
So we can track their dive behavior when they get to the ocean. We want it to stay on for about 8 months until they molt again. Preliminary results do show that the pups are diving longer that have been supplemented, and it seems to last for about as long as you would expect that protein turnover for like hemoglobin to occur.
While it will take some time to work up all the samples, the research team is already discovering other interesting preliminary results, which could be significant for human health research down the road.
Earlier in the project, I was giving the pup an oral administration of one really rare iron isotope, and we were giving them another one intravenously. And so then we were able to take a blood sample at the end of lactation, and we were able to see where those rare isotopes ended up and how well they had actually used what was given orally or in the stomach, and how well they were able to use the iron that was in the bloodstream to make hemoglobin. So when you compare the gray seal pups to like human babies, they were able to use iron that they were fed much more efficiently, and then once it made it across the gut, they were able to use that and incorporate it more efficiently too. We still really don't know how they're moving around so much iron in their bodies without seeing any pathology that you would see in other terrestrial mammals and humans. There's a protein that will transport a lot of the iron, transferrin, and in humans above 45% saturation, you start to see a lot of that pathology. And for some of these seals during lactation, when they're mobilizing just these enormous quantities of iron, we see more than 90% of that transferrin. And so how they're able to do that would be very interesting for humans.
Just as the seals eventually return to the sea, so the human visitors must also leave this shifting sandbar.
Being able to just see all the animals in this really raw environment has been very rewarding and just an amazing thing to see as an ecologist.
I love it out here. It's an adventure every day.
This is a gem. It's so unique, it just transforms you, and you can see the raw force of nature.
Major funding for this program was provided by the Batchelor Foundation, encouraging people to preserve and protect America's underwater resources. Additional funding was provided by the Perot Family Endowment for Environmental Education.